Welcome to homework.
Okay, what I have drawn here is a magnetic field in red arrows, and then the blue vector arrow, and it represents a proton traveling in this magnetic field. Given to us is that the proton is traveling at an angle of 23 degrees. The magnetic field strength is 2.60 milliteslas, which I have converted to teslas by dividing by 1,000. I moved my decimal back 3 places, as you can see here. My force, magnetic field force, is 6.50 times 10 to the negative 17 newtons. Two things not given to us, but we'll need to know is Q, or the charge on a proton, which is 1.6 times 10 to the negative 19 coulombs. And the mass of a proton, which is 1.67 times 10 to the negative 27 kilograms. The general formula is force equals the number of particles traveling through the magnetic field times the charge of those particles times the velocity of those particles times the magnetic field strength times the sine of the angle. Now, we don't need N because we're only dealing with one particle. In rearranging this formula for V, we have F divided by Q beta, with magnetic field strength, times the sine of theta. All right? Replacing those numbers. Now, instead of using these units here, which are personality units, like Mr. Tesla and Mr. Newton, we're going to use the fundamental units. So instead of writing, for instance, fourth, I'll write 6.50 times 10 to the negative 17. But I'll write the fundamental units of kilograms times meters times second squared. Excuse me. And I'm going to divide this all by Q, which is 1.6 times 10 to the negative 19. Instead of writing coulombs, I'm going to write angstroms per second. Amperes times seconds, excuse me. And then for beta, the field strength, I'm going to write 0.0026. And instead of writing teslas, I'm going to write kilogram divided by second squared times ampere. All right? And then, of course, I have my sine of my angle, which is 23 degrees. 23 degrees. Make sure you're in degrees on your calculator. Now, multiplying, dividing, multiplying, we get 4.1 meters per second. Excuse me, I'm missing like a times 10 to the fifth meters per second. Now, if we come on back here, I just want to show you how these units cancel out. So our seconds squared cancel out, our kilograms cancel out, our amperes cancel out. We're left with meters per second. So this is another way to check to see if you've done the right math by checking the units. Right? Now I'm going to go to the next page. And the question B asks for the energy in electron volts. So we start with our kinetic energy formula, 1/2 mass times velocity squared, and we get 1/2 times the mass is 1.67 times 10 to the negative 27 times our velocity that we just calculated in A, 4.1 times 10 to the fifth meters per second squared. And this is kilograms over here, right? Multiplying this out, we get 1.368 times 10 to the negative 16 kilograms per meter squared per second squared, which, by the way, this is, let me make that a little neater. Second squared, which is really a joule. Okay. Now we want this in electron volts. So if I write this number again, 1.36 times 10 to the negative 16 joules, we know that in 1 joule there is 6.24 times 10 to the 18th electron volts. And multiplying this out, we get 854 eV. And that is our answer. 1. Let me go back to A and square off my answer to A.